Oh, Andy. Email address. What's your email address?
Andy@cal.org.
Yeah.
You send me the invite?
Mm-hmm.
What's yours?
No, I did not make that. Okay. No, I'm sorry. It's what I'm watching. Yes, since that came at 3 o'clock on time. Don't have any evidence.
Okay. Yeah, I'm just gonna send it straight. I'm just gonna send you a link. For some reason, sometimes it doesn't do it.
Or you can paste it in the Slack.
Yeah, just email it real quick. All right, sent. Not in Slack. I just sent you.
Or send an email.
Yeah.
I see the Wi-Fi thing.
Yeah, it's easier. Yeah, it's
Oh, there it is.
Try one more time. Yeah, there you go. Yeah.
It's 252.
All right, is there crush?
Should we restart the router before we do this?
You just hit the screen share, which is a green screen. Yep. And say share.
Yeah. Earlier, like certain words.
Okay, perfect.
At least it's fun. And Frank.
Well, right now I'm on your screen. So.
All right. Hello, everybody. My name is Andy Howell. I'll be running this Python services workshop. My background is out of basically system administration. I've worked at Scripps Networks for about 17 years. Currently, for the last several years, managing a cloud engineering team and doing infrastructure in the cloud, as well as other things. As of last weekend, LOPS of a National System Administrator nonprofit. So, who has used AWS? A handful of people. Who uses it regularly? A couple of guys. All right. So it's probably worth going over what we'll be doing, what I'm setting up here. So this is a repo I've got on GitHub on VT102/KnoxPy-serverless. If anybody wants to go look, you'll find a CloudFormation directory. And what a CloudFormation template is a data structure that I can hand off to Amazon and tell Amazon what I want to build. I come over here and I will look. Right here is the vpc.yaml. That is done. That's my actual data. I'll tell you what. Let's look at the other one first. KnoxPy DNS. That is the zone.yaml template. It's pretty simple and straightforward. I guess that's really neat. Okay. This is, think of this as almost like a function, right? So I've created a function to create a DNS zone. Hand this off to Amazon. It's got a parameter. In this case, I've set up knoxpy.calo.org. I told it, here's a resource I want you to build. It's a DNS zone inside AWS, and the name of that zone is whatever parameter I've passed it. Create a DNS zone in AWS called knoxpy.calo.org that we'll be using this evening. I can change this over here. Oh man, this is. This is the command I use to actually give this data structure to Amazon and create this zone. I can change this. It's going to go launch. It's going to create another domain. Especially for DNS, more I have to do to make that useful, but it will exist inside Amazon. We come over here and see. Goodness gracious. Set up the correct account. And now we can see it's going and creating a new stack. Follow the events and see what it's making. I can see what resources it's made. We look at the ones we're going to use tonight, KnoxPy DNS. You see it created one thing, it created a hosted zone. And inside the console here, I can see it as it's been made. It's actually got records for KnoxPy.calo. Any questions about that? Fundamentally, I can take this data structure, I can reuse it, right? So I can give everybody in this room their own DNS name by running that template with different parameters. We call that kind of data structure as code. It's pretty useful. If you look at the other templates in here, I've got a VPC template. So this is a data center. This is going to be our virtual private cloud that we're going to run in. As you can see, it's a little more complex. It creates a lot more things. That's pretty much subnets, pretty much routers. It's giving me a place to install stuff. So between these two, now I've got a data center, now I've got DNS for us to work on.
Hey, quick question. So this allows you to create all resources. Is it as easy as like just saying like delete this template and it will undo?
Theoretically, yes. There could be some gotchas. What you'll see, I'm going to do that. I'm going to spin everybody on their own server. And doing that, I'm going to put some artifacts around. It won't quite clean those up because I'm going to create them as part of the server. Since I didn't do it in the template, I go delete it. It's going to say, hey, whatever. There's some stuff around. I don't want to delete that for you. So, if you build it right, it will. And I took a couple shortcuts. Had to wait for that. All right, so any questions about that before we move on? Does that make sense?
Just back up real quick.
Yep.
You just did use what would you call the technology?
Well,
Or
the AWS service is
Right.
cloud formation.
so you use cloud formation to build infrastructure.
Yeah. AWS has a few services. For example, we're going to start out with EC2, virtualization service. We're going to run a virtual Ubuntu server in this virtual data center that I've created. We end up running a Lambda, which is going to be serverless Python. Some of the assets utilize the S3 storage service. There's cloud formation, IAM permission. So there's a lot of different services that I'm making use of. That's what you don't need to worry about. I'm taking care of it for you. Interesting. It's going to give you a little context of what we do as we go forward. For example, food. So I can come in here and I can just keep that stack. And it'll go away. It'll be as if it never existed. I wanted to go ahead and set up the DNS template ahead of time because I have to hook that into the cal.org domain so the subdomain works. And I don't really have a way to automate that. But I'm going to spin up servers for everybody, and you can see me do that. Let's see what we got. All right. Everybody cross your fingers. This works. So I need some names, and that could be your name. It could be dog's name, could be a noun, something that you remember it's unique to you to do this act. Right? Oh. I wasn't sure. All right. Next. Josh. Zach. Z-A-C-H.
Yes.
Okay. Sure. Yeah. You don't actually have to do anything.
Right, well, you can put Alex then.
All right, Alex. If you want to, you'll be able to log in. Mike. James. Buddy, are you gonna? Do you want to log in?
Yes.
Oh.
Lee.
Lee. L-E-E.
I-O-Y-N-N.
L-Y.
Yes. Okay. Good.
Dane, D-A-I-N.
D-A-I-N-E.
I'm working with Dane.
Okay. Mock. No C-H.
Dale.
Dale. Tom, C-O-N-E. C-O-N-E.
John with an H.
At the end.
John with an
No.
I was on the phone with somebody and I was trying to tell them what to type. I said, write A as in alpha, B as in beta, C as in Charlie.
Oh.
It didn't work. I went physically to them and they had written A as in alpha, B as in beta. All right, Alex, you gonna do it? Alex?
A beer.
Beer?
Hmm.
Excellent.
Let's see here.
Some names here.
Okay.
I do have an SSH card. Okay.
All right, so I'm gonna write a little
An
script
hour and a half.
to iterate through the names. And let's do that here, right? So. Instead of echoing the name, we're going to launch a stack with your name. And just add a little sanity. I'm going to sleep 1 second, right? So we're going to go through everybody's names. I'm going to launch a stack from that server.yaml file. So you can dig through there and see what's really going on. I have to throw this additional flag in here, which just says, hey, I understand I'm creating permissions as part of this, right? I'm creating an account that can do things. Giving it a stack name of your name. So when we look at the cloud stacks, we're going to see, Mike and Lynn and whatever else. Sleep for 1 second, then do the next one, right through this. I don't typically do live demos, and I've never done a workshop. So bear with me. This is quite
spin up that quick?
Very brave.
Sleep for a second?
It's going to take about 5 minutes per step.
Oh, gotcha, but it completes the command. There's something else.
Yes, right. So there is a wait command. So I could come in here, I could say like AWS CloudFormation on stack completion for stack name bug. And it'll sit there and hold, just idle, check every few seconds, and when it detects the stack's done, it returns. All right, so we are good there. We come over to the CloudFormation console. We refresh. We see a whole lot of creation in progress. We pick one at random here. We can kind of follow events. There's a couple of resources I'm creating that they take a little while to work through. So we've got about 5 minutes while these all get created. What I'm doing is I'm creating an EC2 server, right? So a virtual machine in that data center we built earlier. I'm opening up a couple of ports. I'm opening up the SSH port, port 8088, which is where we'll run our services. I am downloading that Git repo onto that server. I am downloading the SSH key we'll all use. I'm creating a static website in S3. I'm putting those files in that website, so this to it. I'm creating a DNS name so you can SSH into the EC2 server. I'm creating a second DNS name that you can go to your own little website and download the create your own keys or authentication or anything from your EC2 server. You have permission to AWS to run what you want.
Is all that in the YAML files?
Yes. Yeah. We come back over here and look at server.yaml, where you can start to see, first you get the parameters, right? Actually, whatever, this is kind of the default thing I've got, but I could run Ubuntu 17.04, right? I could run Debian 8 or an AWS Linux. I'm doing Ubuntu 16. Use a different SSH key, which kind of break them option. I can choose larger instances, right? What VPC I'm building in. So the nice thing about this is my VPC stack, I export out the information I need to build in there, right? So on my server template, I import. So I don't need to know what subnets it's got. I don't need to know anything about that VPC. I can just say, hey, get your info from that stack. So I can take that VPC, I can create centers, all of the same IPs, all the different IPs. I don't have to worry about it. I can just point my server at a particular data center and it'll spin up in it.
Just out of curiosity, when you open up reports, is it just a port 80 or whatever to everyone, or did you already have that?
In this case, I have
this one. Okay.
You can. Right here, this is like a listing of whatever the OS is, right? So I can make this a little more flexible without having to remember AMI, 7D83, whatever. Let's see. So there are my security rules, right? We're opening 22 and 8088 to everybody. And you can dig down here and kind of see all the this. I'm using like the cloud tools to position files. Some of their commands I'm actually running. You can see right here, I clone that repo onto the server. Mostly just so you don't have to do it, right? If we come over here, we can see I had 6 things in KnoxPy.cal.org. No, we still have 6. A lot more here soon.
Well, it's feeling when you write some different components from probably things you've written in the past, and kind of piece things together based on your experience and knowledge having used AWS. That when you say take on a new project altogether, you just kind of take pieces and kind of, and, I mean, I guess just from your, to know how it all works together, piece it up, and now you have a toolbox.
For the most part. Look at what this is, right? I mean, this is it's a data structure, right? It's not really like a programming language or anything else. It's a data structure. Really, what it is, I'm calling an Amazon API data structure that I'm passing it. For me, as I did, to sit down and write out the data structure, that's a little unusual. In reality, for the VPC template, and not only the VPC template, because I've done this in the past, right? I've got a Python script using a module called Troposphere. Right? So what Troposphere does is it lets me build that data structure in Python. So now I've got, instead of an EC2, I've got an EC2 object, and I can do things like copy the object, put it in a logic loop. In reality, Amazon has regions. Right? Those regions are widely geographically separated. Each region has multiple availability zones, which are essentially data centers. So we pick US East, one of the oldest regions. They've got, let's say they've got 50 data centers around Virginia. Those 5 to me. So I have 1A, 1B, 1C, 1D, 1E. If I go to another region, for example, I'm building this in Ohio, US East 2, I only get 3 availability zones, and the minimum you're guaranteed is 2. So I could go to some regions and only get 2. Is they build a VPC template, and they build it for 2 availability zones because that's what they are going. That's the minimum they're guaranteed. They stick it in US East, they still only choose 2 availability zones. With the logic of Troposphere, I can write my logic out and just iterate through the number of availability zones and generate exactly the template I need. So if I go into US East 1, I get 5 availability zones like I really want. Most of the time.
So your infrastructure as code is basically like Ansible on steroids to the next level for cloud deployment instead of individual servers. And everything for your structure.
Well, it used to be JSON, right? It's just a structure, right? You can imagine, like if I had Ansible as an API and I passed that template to it and it did it then, you would, really what you would do, most of the time, if we go back to that template, inside here, what this really is a shell script, right? When I usually do this, I use shell, right, to configure this server. You might choose to use Ansible, but instead of just writing the scripts out, I usually use some form of configuration management. So Ansible would be something I would use inside CloudFormation. There's an analogy made there for both some form of configuration management. CloudFormation is used to build and destroy.
Okay.
Right. It's not typically used to change the configuration on servers. What I would do is if I usually, in an ideal world, right, if I had a configuration change, I would set it up so that I would destroy the old servers and deploy new servers with the new configuration on it. All right, so I think we're getting pretty close to being done. Whoa, no.
With an H.
I know, I think,
Yeah, the H must go.
I probably ran into
It's like
some
H.
conflicts. That's what you get, joking around. Serious business.
Delete John.
One time I wanted to use my first name because there are like 20 Johns, that's where I work. So I was like, I'm actually going to go with that today. It's not working. It's probably cool that you already have a John stack in there from.
So why did that fail? I don't know. The hint I've got here is that CloudFormation didn't get a signal back. If you look at this, I run through all of these commands, and at the end, I signal back to CloudFormation that everything's good. command in here failed. It could have been, perhaps it wasn't able to clone the repo. It could have been that it wasn't able to reach, some repo that it was installing something from. Could have been anything. I can't check now because when it timed out, CloudFormation rolled everything back and deleted the server. So there's various ways around that. Honestly, most of the time when I'm working through this, I would launch it again, and I'd sit there and wait. Once it was up, I'd SSH in and look at my logs before it got destroyed. You can set it up to export your logs out into AWS, and then you can. So for everybody but John, John works with me, so this is totally cool.
Yeah.
I can run him through this in a private session tomorrow.
Thanks.
All right.
Andy.
Then there's your SSH key. You can now go. Make sure, I don't think it'll work with HTTPS, but you try web-bow win across. That will give you the private key that you can use to SSH on your server. Fingers crossed. To disable that somewhere local drive that your SSH client can access.
You got that into the internet bar?
Yes, yeah. Just in the browser.
And you could,
Yeah. Sorry.
just for a second. So when I can.
You got it, John?
I've written it down.
I'm sorry. Yeah, we're waiting on your stack.
I've written it down though.
Your stack is John without an H.
Oh, without an H?
Yeah.
J-O-N?
It's not done yet.
Okay.
It's heading that way.
Oh.
All right, everybody else got it? That's fine. So you should be able to SSH into your name.knoxpy.cal.org, your username Ubuntu, using key authentication and that key I just sent you. If somebody connects, could you let me know?
Hey,
Excellent.
try again.
Where is the key?
I can use a tech, I don't know, I'm sorry.
Yeah, that's what I'm saying. You also may have to change your permissions to.
Yeah, set it like 600 or something.
Yeah.
Yeah, I'm glad you reminded me.
For the SSH dumb like myself, what I do?
Oh.
I am using the I am using the Linux subsystem though. So
Okay. Yeah.
So change permissions to 600 on the file, and then use SSH-I in reference to the file name.
Yeah.
And then use your apps.
If anybody's having any issues, you can follow along here. I'll try this.
All right.
In theory,
I just checked. Did you get out?
I think so. One thing I didn't do is I didn't put the domain at.
I did. That's what I did. I didn't know. Was that no word about that?
You can do a dash L for this. Yeah. Key the rest.
right? Say thousands and thousands of values. Anybody got it? Anybody still waiting? Need some help?
Got him.
Do what?
Got him.
Great, great. Everybody's.
No.
Everybody's see what we need. All right. So if you look, there'll be a KnoxPy directory in there. You don't need to worry about that right now. I'll kind of go over what we've installed. So the first thing we're going to do is kind of in a traditional mode, we're going to run Python web service from the virtual machine. The code in there, you can add to it if you want. But what I use Flask. There are literally dozens of these. This is not really an endorsement of Flask, although I like it. I know it, so I decided to use it for now. I think you can go pretty far with Flask. Alex, who's the guy that gave all the Flask talks, the young guy?
Sure.
Jerry. Oh, yeah. He gave some really good Flask talks, way beyond anything I can do with it. I would recommend taking a look at it. Here is just about the simplest Flask web application with. We're going to import Flask. We're going to create an instance of it. We're going to create a function that says hi. And what we're going to do is we're going to use a Python function decorator, basically just to register this with Flask, so that whenever anybody hits this service with the route /hi, we're going to return hi. Right, the word's hi. And then this is our main section, right? When we run it, we're going to run it. It's going to listen to every every IP address. It's going to listen on port 8088. I'm going to put it in debug mode so we get some more information. Hey, look at that. You guys have probably already done that. I've got that out of order. All right. So I've got a virtual environment set up. So if you run these commands in yellow, we'll be able to run that small service. If you're not familiar with virtual environments, it's basically just a way for me to wrap up the dependencies we need. In order to run Flask, we have to install it using pip. And this just gives a nice little segregated area for us to run these things out of.
It's dot for source,
Yeah.
and then you're going to activate it.
The second line is .space.env. And you'll know it's working when you see your prompt change like this. Everybody good? Everybody still looking at it?
I'm still trying to get SSH into it.
Okay.
I gotta save my keys at PPK.
Yeah, I did.
The spot I'm in.
All right.
Woohoo!
So you can ignore this first line because I already had you. Oh no, I'm sorry. This is correct. You can cd into the Flask directory, and you can run /test.py. And you're looking for this information right here. You should be able to point a web browser at Alex /hi. All right. There. start seeing this. Even then, you can open up a web browser. Let's see. All right, so you've got it running. Now you should be able to go to http://name.knoxpy.cal.org:8080. The browser should say hi. Hi as a service. You no longer have to tell people hi yourself. You can access this through a computer. Until I tell your service that, now you can only work with me. If you go back to your command line window, you can see it reporting information about your connection. Logs, like the source IP address, data information, path information, return code. This right here will take you pretty far. There's a lot of improvements you can make to it. You can get a more performant, like Python instance running on it for expanding huge amounts of traffic. It doesn't take a whole lot to get started. We go back and look at the source. Anybody want to recommend an improvement we can make to this? I can follow this pattern. We have /by. And the function say by, return by. Now I've got two routes for my web service, right? You can hit it /hi, you can hit it /by. I can set up a route which is just /, and that's the default that anybody would get when they hit it. I can accept arguments. So you can set up /hi, question mark, count 5, and give you 5 highs. Oh, yeah, line, sorry.
If you run on 80 and it would automatically this issue.
Yes. Yeah, you can do any port you want. So go back to your command window, type Control-C. That will exit you out of that test.py. Service.py, which is slightly more interesting. So you can run that /service.py. And there's two routes you can use for this. /UUID, which will give you a randomly generated UUID. And /rand, which will give you a random float between 0 and 1, 0.0 and 1.0. We can take a look in here and you can see, right? It's a little more robust, not a lot more complicated. We have /UUID route. If I had been thinking, I would have taken arguments inside there, but what I did, I just do the let's see, more traditional arguments. So you can do like question mark, count there. I wonder. So here's the question mark count equals 100. I get 100 UIDs. I added a little wrapper here so that it detects you're using Chrome, Firefox, or Safari, or JSON, and put it in a pre-formatted tag just to make things a little easier to read your browser. Same thing for RAND. And I can add a second argument, seed. So now generates the random numbers from the seed, so they'll always be identical every time I connect to it. Any questions about that? You can see here I call it from the command line. Obviously, I can stick that into the program. But there's a random.org, which they do a really serious effort in generating truly random numbers and providing that as a service. This is our cheap imitation of it. When you're done, you can Control C out of that. Just type CD, go back to the root area, type deactivate to get out of that virtual environment. If I were going to make, let's say random.org, I was going to create my own random org, my value adds, I also provide UUIDs. I want my service to stay up. So right now we've got a single virtual machine. It's pretty small. It's going to cost about $8 a month. I want a redundant service though, so I need more than one machine. I mean, Amazon goes down all the time. It happens. So I need 2 servers and a load balancer. 2 servers, $8 each, and now it's $16 a month. My load balancer will probably cost about $16 a month, so settling up to $32. I'm not generating any revenue, so that's not great. We can actually do things much cheaper than that. We'll see how. With serverless, my Python code off to Amazon, they run it for me. Right? So I don't need that EC2 instance. I don't need to worry about my virtual environment or any of that stuff. Calls my random service, right? I haven't begun to hockey stick yet. I don't pay anything. Right? So now I've gone from like $30 a month to basically zero. They auto scale for you, right? So they've got a load balancer out in front. It's redundant. If 5 people hit it at the same time, it'll spin up 5 instances of my service, and everybody gets it. Here is a simple Lambda function. Right? So there's no name. You have to tell Amazon what your entry point is. So in this case, it's going to be Lambda handler. It takes 2 parameters, a bit parameter, which is basically the input to this function. So, for example, for the random, it's going to be seed, it's going to be count, it's going to be those parameters. There's also context. This is not a simple data structure. It's actually an object that gives me information about my running environment. A Lambda function can only run for 5 minutes before Amazon kills it. I can query my context object. You can tell me how much runtime I have left. You can tell me how much memory I'm using. There's a limit when I configure the Lambda function. Let's let us configure a Lambda function like that. Hey, or I've already got one. How about that? KnoxPy is the Lambda function that I showed in that slide. If you want, you can execute this right here. So the first thing you're going to need to do is configure a region. So just a little environment variable. Tell it you're going to run out of Ohio. And then you should be able to just type that line in. AWS Lambda invoke the function name we want to call, KnoxPy, and whatever file you want to collect. Here, output file, so it didn't work. Right. We had a problem. We can get a guess here, right? We have a key error around key 1. So we got it. We go back and look at our hello world function. I'm expecting in my event to have 3 key value pairs, key 1, key 2, key 3. And the only thing I do is I return back the value of key 1. When I call that here, I didn't give it the parameters. So down there, we go for one line. Here's how I can build a data payload to pass to Lambda. Key 1 foo, key 2 bar, key 3 baz, 200. But you'll notice I didn't get my function error. And then I cat foo.text, I have my value for key 1. So you can run this. I think generally people are going to look at that and say, how in the world do I use that, right?
That is code 200 even if that function returns out.
Well, it was successful. Right? The call was successful. The API call was successful. Lambda worked.
Okay.
The thing it was using, the function it was calling did not work. So behind the scenes here, what you don't see is like I've got permissions in Amazon basically tied to your EC2 server that'll invoke Lambda. You're returning this as a service open to the world, then you have to worry about how to authenticate all those users. How do I find every new user who joins the service and give them permission to invoke Lambda? How do you use Lambda? Lambda alone like this, we use a lot of internal automation, right? So it becomes like a microservice or something like part of other services. We use it a lot to create automation around creating new stacks. Like if we have something that's a little more complex than the CloudFormation templates I showed you, I may create a land. Well, a great example is I created the foo.knoxpy.cal.org domain. Cal.org doesn't exist in Amazon, it exists in service. When I generate that domain, I've got NS servers, and I have to go back to cal.org or knoxpy.cal.org and say, hey, you need to redirect this foo.cal.org to these name servers, right? There's a disconnect there. I don't have, CloudFormation doesn't know every DNS provider in the world, but as long as my DNS provider has got an API, I can write a Lambda function which serves as an intermediary. I can get the information from the resource I created, hand off to Lambda. Lambda knows how to communicate to CloudFormation. I know how to write code interface to the API of my DNS provider. I do that. I get the status code back from them. I translate that into something CloudFormation understands, and now I can create a DNS zone for an external DNS provider. Works pretty well. I didn't have time to have a demo, but I've done it a few times. All right. The solution there is if we do create a service we want to expose directly to the public, we want to use an API gateway. Right? So now that gives me my port 8088 or whatever port you want interface into Lambda. There's a few other things you can do, like the SQS service, which is the queuing service inside Amazon. It's very full featured, but for now we're just going to concentrate on the API gateway, which gives us an equivalent of a Flask, right, to be able to hit it over a web port. This is an example of what you might design using a Lambda and API gateway. So these are your Lambda functions, right? In this case, right, they've got 3 different Lambda functions: add employee, get employee, delete employee. Back here's a database or whatever other service you want. In front of it is your API gateway, which is sort of organizing the routing. So /hi/by/UUID. Handle redirecting those to the correct Lambda functions. In addition, you can look at your REST actions. You can do authentication of the API gateway. You can do all sorts of stuff. It doesn't have to be only Lambda functions behind there. I can combine EC2 and Lambda on the back end. So if I start out with EC2 servers and decide I want to go to Lambda, or vice versa, maybe my random service starts to hockey stick on Lambda, and eventually it starts costing me real money, and I start to care about performance. I then want to start cramming those into optimized EC2 instances, and at that point, it may make more sense. It may make more economic sense to do that. I can keep my endpoint the same, and on the back end, kind of change where I route things. Yes.
When you're integrating with all the other stuff, how do you set up your development environment to where you can't, if you have a queue or something like that, you can't really have a queue running on your laptop, right? It has to be running on AWS to test your Lambda functions. So how do you emulate that somehow?
So multiple ways. Like the first thing that jumps out to me is I'm creating my queues and everything else with CloudFormation. Right? I can take my CloudFormation template that I created production from the same account, call it Andy's test environment, and I have an exact copy of production. I don't see people running full environments on their laptops like that. So if you have something that's integrated with the AWS services, you typically just don't run it all on your laptop. You tend to run that in the development environment in AWS. Now, what I have seen plenty of people, they rig up a way to work on one locally, just either running the Python script itself or incorporating it in Docker. I've even seen you say like it's triggered by SQS. I've seen a utility that will simulate SQS, right? Under the covers, right, with Lambda, in the real world, I don't need to know SQS or anything about the service that is talking to me because I get it in an event data structure. Just make sure that to simulate SQS calling this, format the event. And we'll look at that a little bit. Because I've got an API gateway in front of it, I have to look at particular fields in that data structure that wouldn't be there for SQS call. All right. So now I've got multiple Lambda functions I've got to put out. I've got an API gateway in front of this. From my experience, I have done this several times in CloudFormation, and it is big and bulky, and there are advantages to it, but a one-night workshop is not the place for that, right? Things into the cloud, and we're going to look at the serverless framework. Kind of like Flask, the serverless frameworks are becoming dime a dozen. There's a lot of them out there. I honestly don't have a lot of experience with many of them. Serverless is probably the most well-known one. There's some that are dedicated to Python. AWS publishes the Chalice framework, which is it's seriously in use by a lot of people. It's a major project. if you look, do you want, I've got a serverless project set up for you. It's actually important that you do this though. I've got a little shell script. All it does is goes into the serverless configuration file and changes the generic name to your specific name. So make sure that, it doesn't really matter, but I would try and just make that name match whatever you configured your stack as. Right now, if we all do a serverless deploy, we're all going to be deploying the exact same service. Right? We'll be stepping on each other. Right? This will allow us to split it out and run 20 different serverless functions. Everybody got it? We'll move on. What we configure, it's very analogous to the CloudFormation template. In fact, I can include CloudFormation snippets in here, but there's a lot of shortcuts. The main thing we did was change the service name, change it to Andy. I have to tell it we are running on AWS. It also does, I mean, everybody's doing serverless anymore. I think we can handle Azure, Google, or anybody else. And there's a configuration information Amazon requires. I have to tell it this is a Python 3 environment. There's a staging name. So what you'll see is I could have a dev and a prod stage and control deployments to them separately. And then here's my route. Right? Underneath functions, we've got my UUID route. I have my rand route. I point it to basically the local file system. You'll see a gen_uuid.py, a gen_rand.py that contain these functions in the same directory. The events, I'm only looking at a get, right? I can do deletes, I can do puts, whatever. And then you can deploy, once you've got everything configured, you can deploy with serverless deploy -v. -v is just verbose. And you'll see it looks, you're going to see a lot like the events in CloudFormation. Behind the scenes, it's using CloudFormation to deploy your API gateway and Lambda functions. And after it runs through everything, it will drop 2 endpoints down here. You can paste those into your browser and use them just like the Flask endpoints. You can do pretty names there. It's basically good. And then when you're done, paste that in, you get what you had before. That's pretty primitive. Yeah, my stuff's good.
You know how it's handling, how it handles imports? And like if you have a library, isn't it the case that you have to have it zipped up and
Yes.
Does that change?
Yeah, I assume it's easy. Honestly, I haven't done that for serverless. Like I said, most of the time, I have done it in a more manual way, where I am actually managing my own zip file. Typically, like we've done a pipeline, so like every commit builds a new zip file that's versioned in the S3 bucket somewhere.
Okay.
I've never seen anybody roll back, but theoretically, we could roll back to previous versions. Most of them just roll forward and keep pushing out new versions. Yeah, that would have been a good thing to stick in it, but I just didn't think about it.
There's incentive in making that zip as small as possible, right? So that, or does that not matter as much?
I don't think it matters much, right? I mean, if you've got 50 gig zip phones or 100 gig zip phones. I mean, obviously there's upper ends there. I mean, well, there's a limit, I'm sure. I don't know what it is off the top of my head. So, yeah, I mean, it probably is better to be smaller. It's going to be stored as a zip file in S3 for the Lambda functions. They're stored in a zip file in S3 behind the scenes. And there's a cold start, right? When you first hit that Lambda function, it has to spin up like a pre-made Python container. It has to download that zip file. It has to unzip it, register it, and then start. Right? The second time you hit it, they've got it cached in the background, and you don't have to suffer that penalty. So the bigger the zip file, the slower to start. And I assume the same goes for multiple dependencies and everything else, right? It's efficiency. You want it to be efficient.
I don't think there's any cost associated with packaging larger. It's the usage of the function, but I've not looked into whether you get penalized by the size of your dependencies and stuff.
I don't know for sure. I mean, I know it uses S3, and you pay for S3. They may not charge you if it's in Lambda. I don't know.
Right. I haven't seen anything purposely.
And that's about it. Any questions? If you're curious, we can actually go in and see how much this has cost me. I've been able to develop this lab and run it. And unless someone started spinning up Bitcoin money, it shouldn't be very much. $4. Almost all EC2. I'm sure we have not hit the freeze. Got to see the freeze here in Lambda. So last I checked, hey on Lambda, gigabytes per 100 milliseconds. So for every 100 milliseconds of runtime, you pay a cost based on the amount of memory you can use at max. If I take a 1 gigabyte function and I run one Lambda function at a time, and Amazon kills it, I immediately start another one. Keep one function running. I run for 4.5 days. Last time I checked. But you get a significant amount of runtime. I suspect the math is difficult. It's depending on a lot of things. I suspect that obviously at extreme usage, it becomes more economical to switch to the really dense EC2. I'm not 100% sure what point that is.
Maybe can I ask a question about Flask?
Yes.
Just playing around with it just generally. Do you think it's worthwhile as a tool?
Absolutely.
To put out small services? Okay.
Yeah. If I had really spent more time, I would love to have set up like an S3 static site, like an entirely serverless site that hit these services on the back end. You can absolutely do it. I don't think I've got anything running in production with Flask at work, but I did write a page viewer to go through the results of chef runs, right? So it's a simple Flask app that would like deliver the result of like 25 runs based on a particular start number, and I can cycle through it and search and do all sorts of things. So you can definitely do interesting things with Flask. Anybody else? If you want to, you want to run this in your own AWS service, it's obviously going to be some fraction of $4. So I would encourage you to do it. One gives you a free tier of I think about $20 a month. So you should be able to do everything I've done here multiple times for got all my code in that repo. It's not going to work for you out of the gate. For example, the DNS names, you may need to put your own DNS names, but you can create new DNS names in Amazon and use that. And if you've got any questions, you've got to do it on your own. If you've got any questions, just email me, let me know. But the extra would be to delete everybody's password. Yes.
Yeah.